Hi students, today we are going to see the chapter Momentum. This is from ASNE levels and you will be learning more about linear momentum, applying the principle of conservation of momentum, elastic and inelastic collision, and Newton's second law of motion and momentum. Now we are going to understand that understanding momentum and collision. Now what exactly the momentum is? It is a measure of how difficult it is to stop a moving object depending on its mass and speed. So these two things you need to remember. That is two terms you have to remember, that is mass and speed. Studying momentum is crucial to understand collisions in the real world, as it helps predict the motion of objects before and after they collide, ensuring the conservation of momentum in all interactions. So if you can look at the figure, we'll be studying in detail related to this topic. Let's understand this question. Ball A moving towards the right collides with a stationary ball B. Ball A bounces back and ball B moves off slowly to the right. Which has the greater mass, ball A or ball B? So to understand this, first we are going to see the initial momentum. Now initial momentum, here if you see letter P, because we denote momentum by small letter P. So initial momentum, that is mass into velocity. So it will be mass of ball A and velocity of ball A. After collision, it is final momentum is equal to minus of ma va, that is initial momentum A, but that's for ball A, mass of A into velocity A plus mass of B and velocity B. Since A reverses direction, it loses a large amount of momentum. For this to happen, B must be able to provide a large opposing impulse. So this occurs when ball B is more massive than ball A. So what happens then? So ball B has greater mass. Now in all this, when you have studied this previous slide, we need to understand first that what exactly the momentum is, defining the linear momentum. Now from the examples which I've discussed in the previous one, we can see that two quantities are important in understanding collisions. One is the mass m of the object and the second is velocity of the object. So students, you need to remember these two things very, very clearly. Now these are combined to give us single quantity, which is called the linear momentum, or you simply term it as momentum and denoted by small p of an object. So here if you see, we discuss about the mass of the object, the velocity of the object, and when they combine together, we term it as momentum. Let's see how to calculate the momentum. Now here if you see the question, which is given mass of 0.50 kg, stone traveling at 20 meter per second. So what is momentum? Mass into velocity. Now mass is 0.50 kg, velocity is 20 meter per second. So what is the calculation here? P is equal to m into v. So when you calculate, you get 10 kg meter per second. How do you calculate the momentum if the mass is 25,000 kg bus traveling at 20 meter per second? Now what is the formula, students? P is equal to m into v. Momentum is equal to mass into velocity. So you need to write what is given. Now for mass is 25,000 kg. So 25,000 into 20 will give you 5 lakh kg meter per second. So you need to convert it into a simplest form, that is 5 into 10 to power 5 kg meter per second. Please remember that you always have to give your answer in the standard form. Calculate the momentum of an electron traveling at 2 into 10 to power 7 meter per second. So mass of the electron, I'm sure you all remember, 9.1 into 10 to power minus 31 kg, and velocity is mentioned here. It is given 2 into 10 to power 7 meter per second. So what's the formula, students? P is equal to m into v. So calculation again here plays a major role. So how to calculate? So first write down mass and velocity. Now what you have to do, first step to make the easy calculation, so you need to just multiply these numbers. So you get 18.2. Then you take the numbers which are in the power, 10 to the power minus 37 and 10 to the power 7. So now the base are same, so the powers are added. So that means minus 31 plus 7 will give you minus 24. So therefore, what's the momentum? 18.2 into 10 to the power minus 24. Again, repeating the same thing, you please convert into standard form. So it's 1.82 into 10 to the power minus 23 kg meter per second. AS level students and A level, it's very, very important that you should know the scientific notations. You should know how to convert the standard form and the general form to simplify your answer. So your final answer here is 1.82 into 10 to the power minus 23 kg meter per second. Now, two balls, each of mass 0.50 kg collide. Now, please remember the question says it's collide. Show that their total momentum before the collision is equal to their total momentum after the collision. Now, before collision, if we see according to the question, we have ball A as 0.50 kg, velocity is 2 meter per second. That is right. Towards right, okay? So ball B is 0.50 kg, mass remains same. Velocity is minus 3 meter per second. For that, I can just quickly show you the figure so that calculation will be easy for you. So before it is given 2 meter per second and 3 meter per second, and after it's again 2 meter per second and 1 meter per second. So momentum before momentum of A before is V. Momentum of B, which is 0.50, mass remains same, students, into minus 3. So total momentum will be 1 plus and then minus 1.5. You will get minus 0.5 kg meter per second. Now what happens after collision? After collision, again look at the figure. Ball A 0.50 kg, velocity will be minus, that is towards left. Now ball B 0.50 kg, velocity is 1 meter per second, that is right, towards right. So we take it as positive. Momentum of A after and momentum of B after. So once you calculate, students, you will find that both the answers are same. That means momentum, initial momentum before and is equal to the final momentum. So we got the same number. Next topic, very, very important, related to momentum is elastic collision. Now, elastic collision is what exactly what? In this, you need to remember that momentum is conserved and kinetic energy is also conserved. That means when we talk about momentum, m1u1 plus m2u2 is equal to m1v1 plus m2v2. For kinetic energy, again, it's also conserved. So you have to take the formula half m1u1 square plus half m2u2 square is equal to half m1v1 square plus half m2v2 square. So examples are like brilliant balls we talk about, air-tight gliders, collisions between atoms and molecules. But the special property for perfectly elastic collision is that relative speed of approach is actually equal to relative speed of separation. That is u1 minus u2 is equal to v2 minus v1. Then what about inelastic collision? Now here you find, students, that momentum is conserved, but the kinetic energy is not. That means kinetic energy is transformed into heat or sound or deformation or internal energy. For example, car crashes or clay hitting a wall or football being kicked. So here what is happening? Momentum is conserved, but kinetic energy is not conserved. What about collisions in two dimensions? Now, what exactly is two-dimensional collision? It occurs when objects move in more than one direction after colliding. Please remember that it moves in more than one direction. So, unlike one-dimensional collisions, momentum must be conserved in both the direction. What direction are we talking about? This is X direction and Y direction. For example, we talk about snooker, we talk about air hockey pucks or particle collisions. So looking at the figure, if you see here, we have two directions, okay? One here and one the other part. To understand more in detail, we talk about resolving velocity into components. Now, when an object moves at an angle theta, so we term it as horizontal component, we take it as v cos theta. For vertical component, we take it as v sin theta. Now here, if you look at the figure, these vectors, they represent the moment of the colliding balls. And the closed vector triangle, if you see here, it shows that the momentum is conserved in the collision. So this was just the basic of or some terms discussed related to momentum. In the next video, we will be discussing more about it, but please remember certain exam tips that momentum is conserved in all collisions. Students, you often lose marks by writing that momentum is lost, so you need to be very careful. This is incorrect. Instead, you have to write momentum is conserved, but kinetic energy is transformed into other forms. So thank you so much, and the next video will be on momentum and Newton's laws of motion. Thank you.